Hey guys, Mr. Donihoo here. Just going to go through the review that you got in class today. I'm going to start with just simplifying expressions. With this first part, a lot of people are confused just because this 2x is here before the minus 2 with the parentheses. This 2x is just going to slide down and be part of our answer. I'm not going to worry about it right now. But I am going to rewrite this minus 2 over here to the side with everything that's in the parentheses. So I'm going to do this separately. Now the parentheses at this point I think we've figured out is a multiplication. So negative 2 times x, negative 2x, and negative 2 times 5 would be, and this is a big thing, minus a positive 5 and a negative 2. That's a negative 10y. That gives you a completely different answer than if you forgot to change the sign. So now that I've done the distribution, I can bring that down here with that 2x that I left hanging. Okay, some like terms, some x terms that I can combine. So 2 minus 2, and I had a lot of students in class thrown off by this. 2 minus 2. 2 minus 2 is 0. That means that there is no x left over. I had several students try to write down just an x, like 1x. No, 0, gone. Only thing that's left over is the 10y, or the negative 10y. So that makes a huge difference in your answer. If you hadn't changed that earlier, wrong. Alright, part B. Again, I'm going to do it in pieces. I'm going to do this first one here, and then I'm going to work the other one off there to the side. I changed the fraction to a decimal just because it's easier to look at. And you could do that in your calculator, just 5 divided by 2. A lot of this stuff with the numbers, you can do with your calculator on test day. I'm just doing them right now in my head. So distributed with the 2.5 to the 2 and the 4. Now I'm going to go off to the side here and use this negative 3x minus 5. Okay, there is no number here, which means that I'm going to use a 1. If there's not a number written, then it's an invisible 1 there. So multiplying, that's going to be negative 1 times 3, multiplying here. Now again, this is a big thing. These signs are going to make a difference. Negative 1 times negative 5. That's a positive 5. That makes a huge difference, this positive sign, or this plus sign here. That makes a huge difference in your answer. Now that I've distributed for both of these, 5x and the minus 3, those are my like terms, so 5 minus 3, 2 is left over. Negative 10, or minus 10, and a plus 5, I'm going to mark those out. Negative 10 and a plus 5, that's going to be a minus 5, final answer right there. Okay, so that's the simplifying expressions portion. Alright, now perimeter. Perimeter is not all that scary. You're just adding up whatever the sides of the shape are. This shape's a rectangle, so there's the rectangle. I'm going to label the sides 3x minus 7, negative 2x plus 4. Now, since it's a rectangle, the opposite sides are the same, so I'm going to write that in here as well. Opposite side, so negative 2x plus 4. Alright, now I'm just going to go around the shape and combine my terms. I'm going to do the variables first. Partly is because in my answer choices, each variable term is different. So one of those has got to be my answer. So looking at it, I'm going to start with 3x, and I'm going to subtract 2x. So I used both of these. Do that subtraction, that's a 1x. Alright, now I'm going to add in this other positive x, so 1x and a 3x, so I've used that now. That's going to give me a 4. And then my last one, the minus 2x, so 4 minus 2x, or 4x minus 2x, and left over is 2x. Okay, now there's only one option that has got a 2x, so my answer is going to be D. Alright, so that's the perimeter problem. The third one on the page there is going to be the solution set if you have a replacement set. Now here's the equation we're given. Alright, equation because of the equal sign. Very similar to our giddy ups the past couple of days. You can use this in your y equals on your calculator. Now putting this into y equals, where we're going to go from here is the table. on the calculator. So instead of taking each of these and using, okay, x equals -3, and substituting in, okay, x squared, so that would be -3 squared minus 2 times x, which we have to substitute in with a -3, x minus 2, substitute in, -3, -1, -1. And instead of doing that for each of these numbers individually, I'm just going to look in the table at the x values and look at -3, -1, 1, 3, and 5 and see which numbers here give me this for my equation. So I'm looking for, over here for my y value, which x value gives me a y value that's a 14. Well, -3, if you look in the table there, that'll give you a positive 14. -1, no. Positive 1, no. 3, no. Positive 5, that gives you a 14. So here there are actually two answers. -3 and 5 would both be correct. Alright, so that's if you have a replacement set. Throw it in your calculator, take a look. Okay? Now we're going to look at the back page here. So continuous discrete, the biggest thing here is that for a discrete situation, you can't have things cut in half. No halves, or halvesies is what I said in class. So for instance, A is a perfect example. Number of stories, so the number of floors in a building. You'll have the ground floor, first floor, second floor, third floor. Not the first floor plus half a floor. That doesn't make sense for a building. So this would be a discrete situation because you can't cut that in half. Same thing, for example, like a TV set. You're not going to cut a TV set in half and have that in a home. Same for students. Hopefully you wouldn't cut a student in half and put them into a classroom. Some things that would be continuous. For example, F. Time it takes to complete a relay race. You could measure the relay race at 0.25 seconds, or you could measure it at 1.5 seconds, or you could measure it at 3.3 seconds. You can measure any amount of seconds that you want. You can split it in half or divide it however you like. That means this is going to be a continuous situation. A couple others. B isn't exactly straightforward. So if you looked at it or thought of it as a graph, as Monday, Tuesday, Wednesday, at 12 p.m., measure a temperature, Tuesday, measure a temperature, Wednesday, measure a temperature. You're not measuring at Monday evening or Tuesday morning. You're measuring on the one day at 12 o'clock each day. Not connected, that would be a discrete situation. Speed of a car, because if you accelerate from, say, 0 miles per hour to 60 miles per hour, you'd accelerate through all of those numbers. So what I mean is that you could have 25.5 miles per hour. You can divide up miles per hour however you want to. That would be a continuous situation. You can cut that in half. Alright, 5, our domain and range question that's on here with numbers and equations. Very similar to that number 3 earlier. Going to go in y equals -6x plus 2. Now these are range values. So that means that we're looking at our y's here. What that means for us is that were we to go into the calculator again and to y equals and go through and look at the table, that means that now in the table I've got these 3 y values. So what I'm looking for are the x values that are going to fill in and give me that y value. So for example, look in the calculator, in the table, and here, let me pull it up. Okay, so I've got the calculator pulled up here now. So I've got the equation into the y equals. Now I'm going to go second graph to take me to the table here. And looking at it now, again, I'm looking for -22 as a y value. So I'm looking around. No, that's just getting bigger. Go back. So right now I'm just looking through the table on the calculator there. See, so now there's -22 as a y value. that gives me 4 as an x value. So what that tells me here is that if my x is a 4, then my y is negative 22. And if you want to double check that, you can. Negative 6 times 4 plus 2, negative 24 plus 2, that would be negative 22. There we go. Negative 4 gave me a negative 22. So that's one of my answers. And you would just sort through this and find the others. So 4 gives you negative 22. 0 gives you a 2. And last one, looking through 14, there it is. Negative 2 gives you 14. So those would be my 3 answers. Okay, now domain and range with a graph. Here's my graph, range. This is a continuous situation. It's continuous, which means that I'm going to be using inequalities here to write out my range. And again, that's bottom to top. So down here at the bottom, I see, and I'm just going to draw the line on here. There's my lowest point. That's at negative 6. Here's my highest point. That's at positive 3. So bottom to top, that's going to go from negative 6 to positive 3. Now, I do have filled in circles on the top and the bottom here. That means that I'm going to have to include the equal to sign because both of those are filled in. So there we go. Range done. I hope that this was able to help you guys. Good luck tomorrow, and see you in class.